In this lesson, we are going to go over logarithmic applications. So previously we talked about exponential applications. Here we're going to talk about logarithmic applications, which are going to involve solving logarithms. So we'll apply the same principles we talked about, where we get each side to a single log if possible, and then convert it to an exponential equation to solve. So our objective is to use logarithmic functions to solve application problems. So example 1. The average walking speed R of a person living in a city of population P in thousands is modeled by the function R of P is equal to 0.37 ln of P plus 0.05, where R is in feet per second. The population of Kalamazoo is 77,000. Find the average walking speed of people living in Kalamazoo, round to the nearest tenth. So our question, find the average walking speed of people living in Kalamazoo, round to the nearest tenth. So we have our equation. Remember that the population P is in thousands. So when we say that the population of Kalamazoo is 77,000, that's 77 thousands. So here we're using P is 77 because the thousands is already accounted for in the equation. Okay, so we would be finding R of 77, which would be equal to 0.37 ln of 77 plus 0.05. Okay, so we would plug this into the calculator. So we have 0.37 times ln 77 plus 0.05 is equal to 1.657. And our problem says to round to the nearest tenth, which is one place to the right of the decimal. We look next door to determine if the 6 stays the same or goes up. This becomes 1.7, and then the units of the walking speed are feet per second. Okay. Next, find the population of a city where the average walking speed, this should say 2.1 feet per second. Round your answer to the nearest thousand. Okay, so in this case, we don't know the population, but we know R of P. So R of P is equal to 2.1. Okay, and so we have 2.1 is equal to 0.37 ln P plus 0.05. And we have a logarithmic equation where what we're solving for is inside the expression of the logarithm. So we start by subtracting 0.05 from both sides to get 2.05 is equal to 0.37 ln P. Okay, so we divide by 0.37. And if we do that in our calculator, we get a really long decimal, so we're better off leaving it as is. Remember to always round at the end. So this is 2.05 divided by 0.37 equals ln P. Now, in order to solve this, since we have a single logarithm on one side, which was our goal, we convert it to an exponential equation. So we have e to the power of 2.05 divided by 0.37 is equal to P. Okay, so I'm going to go to the next slide. Okay, and we plug this into the calculator. Okay, so we get 254.8. Okay, and we're rounding. Remember, this is like 254,800 something because P is in thousands. So if we're rounding to the nearest thousand, that 8 causes it to become 255. So the answer would be 255 or 255,000, depending on what the boxes would say after this problem. Okay. Next, earthquake magnitude is another application of logarithms. So earthquake magnitude is measured on what is called the Richter scale, where R is equal to log of I over I naught. So I is the intensity of the earthquake. I naught is the intensity of an earthquake with magnitude 0, or the smallest that can be measured. It's really used for size comparison. Okay, and since the scale is logarithmic, an earthquake whose magnitude is 5 is 10 times bigger than an earthquake whose magnitude is 4. So let's do a couple of examples. So the first example, did I split these up? Okay, so on this first slide, we're just going to do example part A, and then on the second slide, we'll do part B. So in California in 1994, there was the Northridge earthquake. So when you see this 10 raised to the power of 6.7 times I naught, this is the intensity. So if we plug this in, we have R is equal to log. Our intensity is 10 to the 6.7 times I naught over I naught. Okay, so in this, I naughts cancel out, and we're left with log of 10 to the 6.7. Using the power rule, the 6.7 comes down in front, so we have 6.7 log 10. Remember that log, when it's just written as log, the base is assumed to be 10. So log base 10 of 10 is just 1. So the answer here, the intensity of this earthquake would be 6.7. Okay, so when you hear like the magnitude on the news of an earthquake, this is what it's referring to. Next, find the magnitude of the earthquake on the Richter scale. So Chile in 1960 had an intensity of 10 raised to the power of 9.5 times I naught. So this, if we plug this in, we have R is equal to log our intensity. Okay, our I naughts cancel out, and we're left with log 10 of 9.5. Using the power rule of logs, 9.5 comes down in front, and log base 10 of 10 is 1, so this is equal to 9.5. So this earthquake had a magnitude of 9.5. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.